everyone, my name is Duisekeyeva. I am an ICT teacher on NIS Taras. Before we start our lesson, please think how this picture relates to our lesson. Yes, you are right. Today we talk about database. Topic of the lesson: entity relationships and normalization. Lesson objectives: understand what an entity and attribute and a relationship are. Understand the different type of relationships between different entities. Understand the purpose of AR diagram. Appreciate that AR diagrams are one way of creating an information model. Identify problems caused by redundancy in a database. Explain the concept of first NF, second NF, and third NF as it applies to a relational database. Normalize an entity to one NF, second NF, and third NF. Success criteria to achieve these lesson objectives. Given some example attributes to able to group them with particular entities. Given a set of entities, describe the relationship between them. Define what the terms entity, attributes, and relationship mean. Create a simple AR diagram given a set of structured data. Create relational constructs. Can explain first NF, second NF, and third NF. Normalize tables to first, second, and third normal forms. Optimize the database physical design.
Please think about what kind of information can we find on social networking sites such as Facebook or Twitter or YouTube. Are you ready to give answer? Possible answers: first it's news, next pictures, after that picture albums, then basic profile details, or possible answer events or posts, then people I am friend with, and finally groups I belong to.
Some interesting information about Facebook. There is a lot of data on Facebook. 1.3 billion users, 80 billion items checked every month, pictures, posts, notes, news, events. Average user creates 100 items per month. And question: how can Facebook give me back my data out of the several trillion items out there? Please think. How can the data be organized so that it finds it quickly? Yes, you are right. The data is organized to make it easy for Facebook to find things.
Now we do some activity grouping data with things. Make a group of 4 and make sure you have some space to work together. After, place the 4th card in gray in a horizontal line with space underneath for other cards. Next, decide which piece of data you most likely to be seen with a particular things on a gray card and place them underneath. After, you should make sure your group can explain why they've placed that piece of data with a particular things. When you give out the generic card set for the 4 Facebook entities and the attributes, tell students that the gray or blue cards were some kind of things that were mentioned in the decision. And the white ones are some another data items that were mentioned or that you see are connected to the Facebook. One possible grouping is maybe, for example, for person it's entity and attributes, name, date of birth, email, hometown. For schools, for event entities, possible answer is text, time, location, URL address. Post entities, field for post its name, start date, end date, hosts, and location. Another possible entities is picture. In picture has attributes such as description, location, and file name. Define new terms such as attributes and entity. In relation to a database, an entity is a single person, place, or things about which data can be stored. In data modeling, a first step in the creation of database, an entity is a some unit of data that can be classified and have state relationships to other entities. What does that means attributes? The details about entities are called attributes. When you design a database, you need to think about which attribute you want to store. In a database of hotels, an individual hotel is the entity, and the attributes could be a ranking, awards, location, photos, rating, and ID number.
We are going to use the concrete card set, getting the students to structure that pool of real data items in the card set according to the data model introduced earlier. The task: give them a copy of Entities.Grade to remind them of the 4 kinds of things. Now we want students to create instance of each entity by grouping together related values that describe that instance. They do this by forming the concrete cards into groups, where each group is a collection of data for a single instance. For example, a person or post and so on. What do you think? What is the differences between an entities and attributes and the instance and values? So, the answer is the question: the entity and its attributes form a pattern of template for each instance with its values. Now check the result and one possible grouping. It's shown on the presentation. What do you think? What is the missing? What did we talk about when we discussed social networking at the start, that it's not represented in all of this information? This is answer for this question: relationships, likes, friended, holds, events, loaded, and other. We will now use specific examples of entities to allow people to explore that relationship between them. The task: please draw a relationship, as many relationships between the instance on both sheets as you can think of. The one possible answer is person, host attends likes event, person likes post, post contains events, persons likes picture. It's we said it is the entity. Discuss in the group what are the entities and relationships exist in social networking sites. Yes, you are right. In Facebook, we have another groups or page. For example, the relationship between person and group, like is a person is in a group, or maybe a person likes a page. What is the main entity relationship diagram? Give definition. Entities can relate to each other in 3 different ways: one-to-one, one-to-many, and many-to-many. You can represent this relationship using an entity relationship diagram. One-to-one, for example, one person has one address. One-to-many, for example, one cinema has many customers. Many-to-many, for example, many subjects can be taken by many students. Now I have the special task for you. Read and listen carefully. How do you read this? Employer assigned department. Yes, you're right. Each employer must be assigned to one and only one department. How do you read this? Employer responsible for department, or its department responsible for employer? What do you think? Good job. Each department may be responsible for one or more employees. Full reading of relationship. Employee assigned to department or department responsible for employer. Each employer must be assigned to one and only one department. Each department may be responsible for one or more employees. How do you read this? Student enrolled in course taken by student. What do you think? Yes, you are right. Each student may be enrolled in one or more courses. Each course may be taken by one or more students. Take a look at the student database example. Notice that the table contains several items of data that are repeated over and over again. Class 5B, tutor Mr. Nogin, room 56. In fact, every student in class in 5B will have these items of data. Repeated data in a database is generally considered a bad thing. It wastes space in the database, it takes time to input, typing the same data over and over, it takes the validation, and mistakes may be the make. It's a pain to update. If class 5B gets a new tutor, we have to find every Mr. Nogin and change it to the new name. So, how do you avoid repeated data? The solution is to split the data. The repeating data is removed from the main table and placed in a table of its own. It's a said normalization.
Okay, welcome to the podcast on database normalization for Comp 3 of A2 Computing. Normalization is the process used to come up with the best possible design for a relational database so that tables are organized such that no data is unnecessarily duplicated, data is consistent throughout the database, the structure of each table is flexible enough to allow you to enter as many or as few items as required. The structure should enable the user to make all kinds of complex queries relating data from different tables. So in order for that to happen, we need to get our database in what's called third normal form. So let's take a look and start this exercise. So here's my set of unnormalized data. Now you can see straight away there's lots of duplication. The module number there, just looking down, there's 100 twice. Level, got 2 twice, 3, there's another 2, a 2, 2 ones, a 2. Duration, again, similar story. So there's lots of duplication of data there. So we want to avoid that. So let's have a look at getting this into first normal form. Now, first step of getting into first normal form is to split it up so that there's a table who has attributes that repeat and attributes that are not repeating. So if we look back at our unnormalized data, you can see that the module number repeats, the level repeats, the module name repeats, the duration repeats, the completion date repeats, and the result repeats. The only thing that doesn't repeat is these four here, the first name, the last name, the trainee number, and date of birth. So I'm going to split that up. So trainee number, let's just drag these out. Then we've got the module number. Okay, so that's the first step. The second step, in each table we need to identify an attribute which can be used as a unique identifier, the primary key. So I need to drag my primary key symbol across. So in the first table it's obvious because the trainee number is what we're going to use, just like a membership number for a video. Excuse me. In here, well, again, it's fairly obvious. We're going to have the module number. The module number is the thing that uniquely identifies a particular module. Now, we've got a bit of a problem here, is because the module number is not fully unique, because if we look back, you can see that that module number repeats several times, otherwise it wouldn't be in the repeating table. Now, we've got to add something here that's going to make it unique. Now, to do that, what we have to do is we have to take one of the attributes from the top table and bring it down into the second. So I'm just going to make space for it. Now the attribute we always bring is the primary key of the other table. So in this case it's trainee number. And we make that a key as well. So you can see that a repeating table has a composite key of module number and trainee number. And if I put them together, module number 100, Benjamin Boateng, or sorry, module number 100, trainee number 800123, you can see that's a unique combination. So that is then our key for here. Okay. So there is our table in first normal form. So let's move on. Okay, so to get a table into second normal form, we're only concerned with attributes that have more than one key. So we've got one table here that's already in second normal form because it's only got the one key. So we're going to move that across. Okay, to be in second normal form, each attribute requires all parts of the key to uniquely identify it. Check that each attribute is dependent on the primary key. So looking at this, well, my module name is dependent on my module number, not so much on the trainee number. The level, well, that's dependent on the module number as well. Module duration, module number. Date completed, well, that needs the module number and also the trainee number, because obviously different trainees could complete it at different types. And the same goes for result. So I'm going to split this into two tables. Oops. Take that out, wrong place. Okay, so I've taken that out and I've split them up. Okay, as you can see, there's a link between the two there, because obviously I've got module number up there. So this is all in second normal form. Okay, finally we need to move it into third normal form. So we take our second normal form data, and our statement reads, all non-key attributes must depend only on the key. Look at the table in second normal form and move any attributes that are not totally dependent on their keys to form a new table. Well, first name is dependent on the trainee number, last name is dependent on the trainee number, and date of birth is dependent on the trainee number. So I'm just going to move them all across there. I'm happy with those. Okay, now let's have a look at my table again. So I've got a table there, module number, module name, level, and module duration. So it's these four here. Well, looking down here, it looks as though the level is dependent on the module duration. Okay, it's not fully dependent on the key, so I'm going to split them up. I'm going to move this in here, module number, module name, put this in like that. Looking at this last one, date completed, fully dependent on the key, result, fully dependent on the key, so I'm going to move them across. Excuse me. Okay, so we need to have a primary key for this table, so I'm going to make it level. We need to link it back to the table we've taken it from. So again, I'm going to put level in here as a foreign key, because that just maintains the link. Okay, so that's us fully in third normal form. So that's a step through the process of getting a database from unnormalized form into third normal form.
The school administration decided to keep the information about students' progress in the database. For all students, we need to save all terms progress and all subjects. In addition, we need information about age, gender, and location or address of students. Please help to build this database.
So Adalia, how you can solve this problem?
Okay, in order to solve this problem, first of all, we must to create the tables which has an entity which called full name, and the attributes such as subjects and 4 terms, summary evaluation, age and address. In order to overcome this problem, we must analyze the tables. We have a table which has a fields ID, full name, subject, summary evaluation, grade, age and address. And here field class is not enough because the name of a quarter will be repeated in different classes. And we must add a surrogate key. First step of normalization needs a primary key. A primary key is a main key which all of the fields depend on this. And here the fields must be divided by several parts, and other fields must be depends on primary key. In second steps of normalization, we must to have a primary key and a foreign key. The fields age and address information depends on the ID key. It means that the in first table, which name is students, ID students is primary key, and in the second table's progress, the ID students it's foreign key. It's create the relationship between both of table. In third step of normalization, we have 5 tables which call the student, subject, progress, grade and terms. Here the main purpose is that we must to create the relationship between non-key attributes, and all of the non-key fields must be related with each other.
Create a database of the school library which has a book collection consisting of educational, scientific, or fiction and so on. Data on school students using different books are included in the library database. One order can contain several different books. Please create a normalized database for our library.
Hey Medina, how we can solve this problem?
So we have a database, and we should identify our primary case. And for example, we draw table library, and we have 2 composite primary cases, and
There are ID students?
Yeah, ID student, and also ID book. Also, we have another attributes as student name, ID, address, and etc.
Grade, tutor. Book name,
General description.
There are very many patterns of
Yeah, a lot of.
this table.
So I normalize my table to first normal form. Can you show me the second form?
Okay. In the second normalization, we'll non-key attributes that depends on primary key, and I will divide the first table into some tables. There are readers, book, and order. In the readers, student name, grade, address, and tutor, there depends on ID students because of ID student is a primary key. Second one, in the second table is the book, book name, author, yearbook, genre, and description. There depends on ID book as its primary key. And in the order table, in the last table, date of day when we take the book, the end when we must give them back. And ID students and ID book, there depends on order ID. And there are foreign key, like ID students has connection with ID students in the table of order. It's a foreign key, FK. And in the book table, in the table of book, ID book is a primary key, and in the table of order, ID book is a non-key, and we have a link with each other.
So Aisana, what should we do in third normal form?
In third normal form, the non-key attributes depends on non-key attributes, and it must be the main rule. It must be consist of second normalization. We must divide tables into several
with the new the new title. Like in the second normalization, we have a table readers, book and order. We will divide readers into two tables, students and grade. Here in student table, the ID student is a primary key, and it consists student name, ID grade, and others. Yeah. And in the second table grade, the primary key is ID grade and tutor.
Okay.
What about the second table?
In table book we have attributes like ID book, book name, author, year book, ID genre, date, and we divided this table into two, and the next second table called genre, and it has attributes like ID genre and genre. ID genre is a primary key in this table, but is a non-key attribute in table book.
And finally, the last table is the order. We wouldn't divide in several tables like this one. It will be same in the second normalization order. Here is the primary key order ID because it's not repeated and it's like atomic. And there are some description date and when we must give the book and ID students and ID book. So in that way we can solve this problem and make a good solution, creating a good database.
Normalization provides rules that helps organize the data efficiently, no duplication, less money needs to be spent on storage, eliminate redundant data much faster to run a query on the data, ensure that only related data are stored in a table, better data integrity and less risk of mistakes. Lesson objectives: understand what an entity and attribute and the relationship are, understand the different types of relationships between different entities, understand the purpose of an ER diagram, appreciate that ER diagram are one way of creating an informational model, identify problems caused by redundancy in a database, explain the concept of first NF, second NF and third NF as it applies to relational database, normalize an entity to one NF, first NF, second NF and third NF. At the end of lesson, give me feedback. Did you learn useful information for yourself? Where did you have difficulties? What would like to explore in the next lesson? Goodbye.